Chapter 9, Section 3 is finding the area of composite figures. We're going to have to put a couple different figures together. So this first one, we're going to find the area of the semicircle. I'm going to put a half there because it's only the circle. And the radius of that circle would be 10. So 1/2 pi times 10 squared. And I'm going to do 0.5 times, I'm just going to use 3.14 times 10 squared. That is 157. So that top part right there is 157. This second part right here is a trapezoid, which is going to be 1/2 base 1. Top base is 20 plus base 2, which is 32, times the height, which is 14. So 0.5 times 20 plus 32 is inside the parentheses, times 14. That makes this piece 364. 157 plus 364 is a total of 521 millimeters squared. This next one, let me see if I can figure out how I'm going to do this. Let's see, this is 8, this is 10, and this is 5. I think what I'm going to do, I'm going to skip that one for right now and come back to it. I want to go to letter D next. And letter D, what I'm going to do is find the area of the triangle, which is 1/2 18 times 26. So 0.5 times 18 times 26, which is 234. And then there's a semicircle there that's taken out, so I'm going to subtract that 1/2 because it's half of a circle. Pi, the radius is going to be 4.5 squared. So 0.5 times 3.14 times 4.5 squared is right about 31.8. And then I'm going to do 234 minus 31.8, and that is right about 202 square feet. Next one, I'm going to find the area of the whole circle. So pi, the radius in this case is going to be 10 times 10 squared, pi r squared. And then I'm going to subtract the area of that trapezoid, which is 1/2 base 1 plus base 2 times the height. So I found the whole circle, and then I subtracted the middle. And I'm going to enter that whole thing into my calculator. 3.14 times 10 squared minus 0.5. Make sure you use your parentheses here. 12 plus 20 times 8. And we end up with 186 centimeters squared. Letter F. If this is the diameter, the radius will be 3. So pi times 3 squared. That's the area of the whole circle. And I'm going to do something different to find the area of the square. In a square, your diagonals are congruent. So that means this diagonal is also 6. And a square is a rhombus. And if you remember back from 9-1, to find the area of a rhombus, we could do 1/2 diagonal 1 times diagonal 2. So if we consider that square a rhombus, and we do 1/2 diagonal 1 times diagonal 2, we can do pi times 3 squared minus 1/2 6 times 6, and we can enter that in our calculator, and we end up with 10.26 inches squared. The next one, I'm going to go to this one. See, we know this is 75. I think I'm going to drop this line right down here. 75 minus 37.5 makes this 37.5. Then we have a rectangle on the left, and we have a triangle on the right. So we have 22.5 times 37.5 plus the triangle, which is 1/2 37.5. We don't have the height though. So to figure out our height, we're actually going to have to do Pythagorean theorem. X squared plus 37.5 squared equals 62.5 squared. And your height in this case ends up being 50. So these two, when we multiply them, give us the area of the rectangle. 1/2 base times height, and we had to figure out the height with the Pythagorean theorem. So 22.5 times 37.5 plus 0.5 times 37.5 times 50, and I've got, and you end up with 1,781.25 square meters. And this one, I did figure out what I was doing wrong. I'm going to flip this thing upside down. And if you do that, see how we have that parallelogram right there? The base is 8 and the height is 5. I'll flip my paper back around. That parallelogram then, base times height, is 8 times 5. And then the rest of that shape is this purple triangle right here. So that will be 1/2 10 times 5. And then we can go 8 times 5 plus 1/2 10 times 5, and the area there is 65 square feet. So if you don't know how to do one the first time you look at it, sometimes you can go back and figure it out. Example 2, company receives an order for 65 pieces of fabric in this shape. Each one needs to be dyed red, and we want 6 inches to dye 6 square inches. 2 ounces of dye is needed. So the question is, how much is needed for the entire order? Well, this shape right here, we have a square, 3 times 3, and if we take these two pieces and put them together, it would be a circle. And the radius of that circle would be 1.25 inches squared, or 1.25 inches, excuse me. So the square plus pi times 1.5 squared, 3 times 3 plus 3.14 times 1.5 squared is right about 16 square inches. So each one of these shapes is 16 square inches. Well, we have 65 of those. So 65 times 16 is 1,044 square inches. Well, in order to dye 6 square inches, we need 2 ounces. So if we do 2 ounces of dye for 6 square inches, notice how 1 square inches is on the top, the other one's on the bottom, and those cancel out. And then you have 1,044 times 2 divided by 6. So you would need 348 ounces of that dye. And letter B, Katie is using a given plan to convert part of her lawn into a garden. So first of all, we need to figure out the area of this. And first one's a rectangle, 28.5 times 7.5. This one is 213.75. The bottom one, 12 times 6, which is 72. And this one in the middle is a trapezoid. So we will have 1/2 base 1 plus base 2 times the height. Make sure you put your parentheses around there. And that one is 90. Adding those together, 213.75 plus 90 plus 72, we have 375.75 square feet. This newly planted garden uses 17 gallons in 1 square foot. Notice again how we have square feet on the top, square feet on the bottom, and those cancel out. Then we take our 375.75 and multiply by 17, and this garden will require 6,387.75 gallons of water per year. Wow. And formula for an irregular shape, area is 1/2 our border points plus all the interior boxes. And then for example B and C, when you have each side, you're going to do 1/2 your border points plus your full interior boxes, and then you're going to multiply it by the area, which in this case we'll call side squared. Now this is an estimate, and what you're actually doing when you do half the border, you're saying some of these are going to be all the way full, some of these are going to be half the way full, so we're just going to count each one of them as a half. So I'm going to start right here. This will be 1, 2, 3, 4, 5, 6, 7, 8, what we call border pieces. And then we have 3 full boxes. So 1/2 the border, we had 8 border pieces. Half of them are full, half of them are closer to empty. We're just going to call them all halves. So this one will have an area of 7. Letter B, I'm going to start up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 border pieces. Full interior boxes, we have 1, 2, 3, 4, 5, 6, 7. So half of our borders plus the interiors. And now this time it says each side is 2. So we have to take that number and multiply it by 2 squared. 1/2 of 14 is 7. Plus 7, 2 squared is 4. And 14 times 4 will be 56 centimeters squared. Example C, the borders 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1/2 of 11. I counted 11 border pieces. The interior ones, 1, 2, 3. And then each side is 5 inches, so 5 squared. That becomes 5.5 plus 3 times 25. And when we multiply, we get approximately 212.5 square inches. This isn't exact. Your answers might be a little different than mine, and they still can be considered correct.